Good evening, everyone. Good evening. Hello everyone. Check audio video is okay or not? Hello everyone. Check audio video is okay or not? Hello everyone. Check audio video is okay. Perfect. Just I done some troubleshooting. Audio is not working little bit. I done some troubleshooting, so I hope now everything is okay. Can you see the problem and try to give answer? So what he is saying is language L contains set of all Turing machines. I am really sorry for inconvenience. See the first problem. Right? Language is equal to set of all Turing machines which will accept all strings of length 2014. All strings of length 2014. Language L contain set of all Turing machines, right, which will accept of string length 2014. Then L is see everyone, right? So language L contains set of all Turing machines which will accept of string of length 2014. What is the meaning? String 2014 length if you give string 2014 length if you give a string of length 2014, Turing machine surely will go to, right, halt to final state. Surely Turing machine will goes to halt to final state. Right, string length of 2014 if you give to a Turing machine, surely it will halt to, and it will go to halt final. Right, if you give string of length 2014 other than that, 2014 other than, what is the meaning? Less than 2014, more than 2014 if you give, right? So let me write now. If you give to the Turing machine 2014 less than, 2014 more than, if you give, anything can happen. What is the meaning? It may go to see this one, it may go to halt to non-final, it may go to hang also. It may go to halt to non-final, it may go to hang also. If you are lucky, right, you will go to halt final. If you are non-lucky, you may go to halt non-final, you may go to hang also. See, hang also. So what I want to say is this is recursive enumerable, REL. What is the meaning? If you are lucky, you will go to halt final. If you are lucky, you will go to halt final. If you are non-lucky, means if you are unlucky, you will go to halt non-final or hang. So that is called REL. REL means what? Valid things you will go to halt final, invalid things you may go to halt non-final or hang also. It is a REL. REL means undecidable also. REL another name is semi-decidable, which is also called undecidable. So let me see the option. If undecidable is there, I have to select undecidable, right? Let me check this one. Undecidable but recursive enumerable. This is also called as semi-decidable. Undecidable but recursively enumerable. Undecidable, right, but recursively enumerable. Please careful. If you see the option A, decidable, no. Right, if you see the option C, undecidable, not recursively, no. Decidable but not recursively enumerable, no. Answer is undecidable but recursively enumerable. It is a really nice question. Valid things it will go to halt final, invalid things will goes to halt non-final or hanging possible. So recursive enumerable. Because of hanging is there, it is not recursive. Suppose assume that for everything either halt final or halt to non-final, that is called recursive. For everything halt final or halt to non-final, valid halt to final, invalid halt to non-final, then it is called recursive. But valid final, right, invalid non-final or hang. So here three possibilities are there. It is a recursive enumerable. Another name is semi-decidable, you can say, undecidable also. Right, undecidable but recursive enumerable. It is a really nice problem. This kind of question can come in the exam. This kind of question can come in the exam. Please take care. Please take care. The reason why it is recursive enumerable is 3 choices. Valid will go to halt final, invalid will goes to halt non-final or hang. Because of hanging is there, it is a recursive enumerable language. This is also called as a hanging Turing machine, right? This is also called hanging means hanging possible, hanging possible. It is not a halting Turing machine, simply Turing machine. When you say every time halt, invalid halt, valid halt, valid halt at final, invalid halt at non-final, that is called halting Turing machine. That language is recursive. But it is not a halting Turing machine, it is a Turing machine. It is a more than halting Turing machine. It is a more than halting Turing machine, means Turing machine. So remember, halting Turing machine is subset of Turing machine. Halting Turing machine is subset of Turing machine. Please be careful. So before the Turing machine, one level is called halting Turing machine, which is also called HTM. Right? This is the TM. Right? Before this HTM. Halting Turing machine, its language is recursive. It is a Turing machine, its language is recursive enumerable. Halting Turing machine having only 2 choices. Final halt, right? Sorry, valid halt final, invalid halt non-final. Only 2 choices. But here 3 choices. If I want to give one example, I can give also. If you open your computer, and if you open the right Gmail, you open the your computer and you open the Gmail. So if you are lucky, it may open. If you are unlucky, it may hang also. There is a chance of hanging. You cannot say that my computer is a MacBook Air, MacBook Pro, my computer never halt. No, there is no guarantee. Even though your computer is MacBook Air, even though your computer is MacBook Pro, no guarantee that it don't hang. It may hang. Try to remember, right? Your computer is a Turing machine. You cannot say your computer is a halting Turing machine. Your computer is a Turing machine. Our life also, right? Almost like halting Turing machine. We don't know what is going to be happen. If you know everything, how you are a human, right? You are going to be a god. We don't know. Anything can happen. Remember 2014, if you give halt, means valid halt, invalid, it may halt, it may hang. Because of that reason, it is called REL, recursive enumerable, right? But recursive enumerable means undecidable. Another name is semi-decidable. Supposition that it is not recursive enumerable also. Let us assume that there is some language which is not recursive enumerable also. That is called undecidable, not semi. Undecidable but not recursive enumerable. That is called completely undecidable. But it is undecidable. For valid thing it is decidable. So it is called semi-decidable. But if you go to the recursive, valid also decidable, invalid also decidable. That is called recursive, which is also called HTM. Everything decidable, that is called HTM. Here valid is decidable, invalid is hanging possible, so undecidable. Suppose everything is undecidable, that is going to be undecidable but not recursive enumerable. Right? Please careful. It is a really nice problem. This kind of question may come in the exam. Please take care. Someone is saying that, hello sir, can you please upload your algorithm and TOC series? Yeah, Sumit, right? My TOC algorithm, data structure, compiler design, right? Computer network, right? In few more days, right? Discrete mathematics, totally 6 subjects. They all are there in the plus course. Live also possible, recording also possible. You take the plus subscription, all are there in the proper order. In the YouTube also they may be there somewhere. If you are really serious, right, take the plus subscription or iconic, you will get the everything in detail. everything in detail, right? Plus course, if you see lecture number 1, this is the topic, lecture number 2, this is the topic, like that 6 subjects are there. Not only me, all the Unacademy top educators videos are there in the plus and iconic. If you are serious, please take subscription, right? So spend almost like remaining 6 months of time, you are going to get very good rank. You are going to get very good rank, trust me, right? Fine. I hope whatever I am saying you understood. Rahul is saying that, sir, can you please explain Rice theorem with this question? So Rice theorem is same, right? Rahul, Rice theorem is same story. What is that one, right? A Turing machine satisfying some property. A Turing machine satisfying some property is undecidable. Non-trivial property of a Turing machine is undecidable. A Turing machine satisfying some property is undecidable. So one more thing, Rahul, Rice theorem, right? Only for joke purpose, actually, to be frank. GATE examination, Rice theorem may not be useful. GATE examination, Rice theorem may not be useful, because all problems looks like I can apply Rice theorem. It look like, right, all problems I can apply Rice theorem. But remember, right, in the undecidability chapter, approximately 30-40 problems are there. Undecidability, approximately 30-40 problems are there, right? I will explain all of them. If you practice those 30 problems, one of the problem will come in exam. Just 30 problems are there. I will explain all of them, right? So one of the problem guarantee will come in the examination. So in plus course or iconic course, I will take one practice class that is called rank improvement course for 2023. There I will explain 30 problems of right, undecidability. One of the question will come. Rice theorem may not work for the GATE examination, because every problem look like Rice theorem possible. That is the problem. Yeah, good evening Ram. Good evening Imanshu. Thank you so much for asking all these things. I'm really happy to give answer for this. Right, let's go to next problem. Can you see this? Can you see this? Can you see this? Which one of the following statement is false? The halting problem of a Turing machine is undecidable. Determining whether two context-free grammars is ambiguous is undecidable. Determining whether a context-free grammar is ambiguous is undecidable. C. Given two arbitrary context-free grammar G1 and G2 is undecidable whether L of G1 is equal to L of G2. Given two regular grammar G1 and G2 is undecidable whether L of G1 is equal to L of G2. So it is a very simple problem. I think we done already practice. Can you check one time? See, one or two problems are tough. See, in undecidability, one or two problems are tough, remaining all very easy. In undecidability, one or two problems are tough, remaining all are very easy. I seen maximum 10 questions are tough. Undecidability, maximum 10 questions are tough, remaining all are easy. What will be the answer for this? I hope this problem very simple to all of you. If anyone don't know, can you see one time? Which of the following statement is false? Option A, the halting problem of your Turing machine is undecidable. True. See this one. The Rice theorem saying that any non-trivial property of Turing machine is undecidable. Any non-trivial property of Turing machine is undecidable. What the meaning of trivial is? Answer known. Answer is yes. Or answer is no. So guarantee. So see, only one answer is there, that is called trivial. Only one answer is there, that is called trivial property. Non-trivial means answer is not one, answer is multiple. Maybe this, maybe that. So the halting problem of your Turing machine is undecidable. What is the meaning? For a Turing machine, if you give any string, right, it may accept, it may reject, it may go to hang. It may accept, it may reject, it may hang. So this is called non-trivial property. This is called non-trivial property. So if the question is like this one, what is the answer? Every Turing machine will start from starting state, right or wrong? Every Turing machine will start execution from starting state, right or wrong? Yes, every Turing machine will start from starting state. This is called trivial property. Turing machine trivial property decidable. So if everyone, a trivial, Rice theorem not talking about trivial property, it is talking about non-trivial property. Non-trivial means, right, maybe yes, maybe no, that is called non-trivial. So let's see this one. For the Turing machine, if you give any string, it may halt, may not halt. May not halt means it may go to hang also. This is a non-trivial property. Non-trivial property of Turing machine is undecidable. Yes. Next one, go to the B. Determining whether a context-free grammar is ambiguous is undecidable. Determining whether a context-free grammar, so you know very well, given context-free grammar is checking is it ambiguous or not, undecidable. True. True. Next one, given two arbitrary CFGs, means CFG1, CFG2, if two grammars are given, right, CFG1, CFG2, two grammar, name